Same type of problem that we both did in class and that there's a previous practice problem about. First, we want to find the slope of the inverse demand curve, right, which is change in P over the change in Q. Then we want to find the equation for the inverse demand curve. The equation for the inverse demand curve, so this thing right here, is going to be P is equal to some intercept B minus, because we know it's a demand curve, change in P over change in Q times Q. That's what we're going to get every time, and we need to know what change in P over change in Q is, and we need to know what this intercept B is. Once we've got that, all we have to do is solve this baby for Q, and we'll have the demand curve, and we can interpret the slope and the intercepts. So first of all, in this case, we have all these points available to us. We only really need one to find the slope. My preference is to use the two intercepts if I have them. So my change in P is $1. Here my change in Q is 200. So my change in P over change in Q is 1 over 200. I should be able to do the same thing here, right? So if I go between A and B, my change in P is 0.1, and my change in Q, I go from 40 to 60, so my change in Q, if I go down from A to B, then it's negative 0.1, and I'm going to get an increase in 20 quantity. 0.1 over 20 is 1 over 200, right? So we've got my slope now, and so now I need to find the intercept. Well, this intercept B is the price if Q is equal to 0. Well, now we have it. It makes it particularly easy. The price for Q equal to 0, and the interpretation of that intercept is at this price, no one wants any. So this is rides per day. I don't know what you're riding. That only costs $1, but good for you. So the equation for the inverse demand curve, P is equal to B minus change in Q over change in P. Change in P over change in Q times Q. P, our intercept is $1. Our slope is 1 over 200. Q, there we go. I always like to check. So let's see what that looks like. Let me pick a point. Here's 40 cents and 120. So let me plug that in. So if I have a Q of 120, then I get 1 minus, let's see what 120 divided by 200 is 0.6. So I get P equals 1 minus 0.6, and that's a price of 40 cents, which is exactly what I should have gotten. So hooray, we can verify that we did that correctly. Now let's solve that for Q. So here's our inverse demand. Okay. Now we're going to solve the inverse demand for Q. So I'm going to add 1 over 200 Q to each side. So P plus 1 over 200 Q is equal to 1. Now I'm going to get the Q by itself, so I'm going to subtract P from each side. 1 200 Q is equal to 1 minus P. And then to get rid of this, I'm going to multiply everything by 200. So if I multiply 1 over 200 by 200, I just get Q. 200 minus 200 P. And again, something is wrong with that, I think. Let me check. So let me take a P. Let me take a P of 60, and I should get, what's that value down there? 80. Okay. So I've got Q is equal to 200 minus 200 times 0.6. Okay, let's try that. 200 times 0.6 is equal to 120. So Q is equal to 200 minus 120, which is equal to 80. And that's what I was supposed to get. So I had a minute where something didn't look right, but I was incorrect. didn't make any math errors, and I found that by checking my work. What does this intercept mean? This means that if this ride were free, people would want 200,000 of them per day, right? And then this slope, if we want to, so here's our demand curve. The slope here is negative 200. That means if price goes up by $1, quantity falls by 200. So apparently people are very sensitive to the price of this particular thing.